Picture this. You're sitting in a Monday morning stand-up meeting.
Oh, we've all been there.
Right. And you're looking at this incredibly polished report, or maybe it's a flawless tech architecture diagram up on the big high-def screen in the conference room. Everything just looks absolutely perfect.
All the pipelines mapped out.
Exactly. The data pipelines are beautiful. The compute power is humming along, no bottlenecks. The deployment metrics look totally solid. I mean, the engineers are practically taking a victory lap at this point.
But you've got that feeling.
Yes. Deep down, looking at all those green check marks, you have this sneaking suspicion that something, somewhere is fundamentally wrong. You can't put your finger on it. It just feels too clean.
It always does when the surface is that polished.
So today, we're going to figure out exactly what that feeling is. And more importantly, how to catch it before it costs your organization an absolute fortune. We are diving into the hidden failures of artificial intelligence.
And just to set the parameters right up front, we are completely ignoring the sci-fi stuff. No apocalyptic sentient robots taking over the world narratives today.
None of that. We're focusing purely on the quiet, everyday, honestly, incredibly mundane failures that just silently bleed millions of dollars from companies. And on a broader cultural scale, how it slowly dilutes human knowledge into this generic paste.
Which is such a critical distinction to make, because these functional failures, they don't look like failures at first glance. They masquerade as massive successes. They look like beautifully rendered Tableau dashboards or perfectly formatted, grammatically flawless paragraphs of text.
Yeah, the illusion of perfection. And today, we have two really fascinating artifacts, really, that pull the curtain back on this. The first is a highly detailed postmortem of a machine learning project at an NBFC.
A non-banking financial company.
Right, based in Pune, India. And it is a brilliant, just brutally honest breakdown of how a technically perfect model failed completely. And what makes it so valuable is we also have the underlying engagement strategies and the comment seeds attached to it.
Showing exactly how this narrative was shopped around internally to force stakeholders to actually pay attention to the problem.
Yeah. And then the second artifact shifts our focus completely. We go from tabular data numbers to generative text. It's this specialized internal Wikipedia field guide that details exactly how large language models betray themselves through these distinct, recognizable writing tics.
What we're calling AI speak.
AI speak, I love that term. So the mission for this deep dive is to uncover exactly why our smartest, most expensive AI systems confidently lie to us. Or, alternatively, why they just bore us to death with generic fluff.
Whether that's silent data rot in a database or the aggressive statistical smoothing of a language model.
Exactly. And we're going to show you exactly how to spot these flaws and fix them at the root level. So I want to speak directly to you listening right now. Whether you're an executive trying to figure out your AI budget this quarter, or a developer actually in the trenches building these pipelines, or honestly just a curious reader who is completely exhausted by robotic text online, this deep dive is going to give you X-ray vision.
You'll be able to see right through that perfect AI facade.
Okay, let's unpack this. We have to start with the Pune NBFC case study because it just so perfectly illustrates the illusion of the perfect architecture.
The setup here is incredibly relatable. Anyone who's managed a data science project or worked in fintech is going to wince at this. We're looking at a team that spent 11 solid weeks building a predictive credit scoring model for this NBFC.
11 weeks. I mean, that's a massive investment.
It's almost an entire business quarter dedicated entirely to engineering one single model. And by all traditional technical measures, they executed it flawlessly. They had the right engineers. They provisioned more than enough compute power to run the models without latency.
Their architecture diagram, going back to that Monday stand-up scenario, it looked incredibly impressive. All the right nodes, the feedback loops.
And the most dangerous part of this whole scenario, the model actually worked.
That's the terrifying part.
It compiled, it processed the inputs, and it spit out predictions exactly as the math dictated it should.
That's the trap, isn't it? It was doing exactly what it was mathematically instructed to do, but then the floor just drops out.
Right.
Because the data, the actual foundational bedrock of everything they had spent 11 weeks and probably hundreds of thousands of dollars building the data, was lying to them.
And not because of some sophisticated cyber attack poisoning the well?
No, it was lying because of sheer mundane neglect. I mean, how do you go 11 weeks into a project without realizing the foundation is completely rotten?
You get there through the siloed nature of modern tech organizations. The engineers building the pipeline just assumed the data engineering team cleaned the database.
Right.
And the data engineering team assumes the legacy system they inherited was accurate. It wasn't until someone on the team finally decided to halt the machine and manually audit the raw training data that the illusion broke. Not the code, not the hyperparameters, but the raw CSV files themselves.
And what they found is just staggering. It should send a chill down the spine of anyone running predictive models. Fully 40% of the historical loan outcomes in their training dataset were mislabeled.
40%. Let that number sink in. 4 out of every 10 data points were explicitly instructing the machine learning model to believe the exact opposite of the truth.
When you look at the specific examples of what this looks like in the database, it's brutal. We are talking about loans that were performing perfectly well. The borrower is making every payment on time, and these were tagged in the system as defaults.
And then on the flip side, you have actual defaults borrowers who ghosted the bank, stopped paying entirely, requiring massive write-offs, and they're hiding safely under the totally benign label of restructured.
And the absolute tragic punchline to this whole setup, the timestamp on those labels, nobody had touched those specific data labels since 2019.
That 2019 timestamp is the smoking gun of data rot. Just think about everything that has happened in the macroeconomy since 2019.
Oh man, a global pandemic, massive interest rate shifts.
Entire industries collapsing and rebuilding. And yet, this NBFC is training a cutting-edge 2024-era neural network on ground truth assumptions that froze in time 5 years ago. It was just sitting there on the server, rotting, while the smartest engineers in the building constructed a beautiful, state-of-the-art mansion right on top of a sinkhole.
Which brings us to a really fundamental reality about supervised machine learning, something that often gets totally obscured by vendor hype. The model learned exactly what the team fed it. It was, as the postmortem brilliantly categorizes it, confidently wrong.
It didn't crash.
Right, it didn't send up a red alert saying, warning, the socioeconomic indicators for these performing loans contradict the default label. It just learned the wrong rules with absolute mathematical perfection.
To really drive this home, the individual who documented this failure used this fantastic analogy. They argued that an ML model learns the exact same way a human toddler learns to tell a mango from an apple.
Show me an example.
You show the kid labeled examples
No.
over and over again. Now imagine you keep pointing at a ripe, yellow-orange mango, and every single time you point to it, you look the kid in the eye and say, apple.
If you repeat that enough times, the kid doesn't develop some complex philosophical understanding of fruit taxonomy.
No, the kid doesn't get confused. The kid simply becomes absolutely 100% certain that those yellow-orange objects are called apples.
That is precisely what happened with this credit scoring model. You feed a sophisticated algorithm 40% bad data, it doesn't question the data, it just becomes incredibly confident in its own flawed logic. It learns that performing loans possess the characteristics of defaults.
And that massive defaults are just perfectly fine, normal business operations.
The postmortem actually includes the specific text prompt the author used in an image generator to create the thumbnail for their internal presentation. And it's so visually striking, I have to break it down. It paints the picture of this analogy perfectly.
It's a great example of how to communicate technical failure to non-technical stakeholders.
Exactly. The prompt asks for a clean, minimal editorial-style illustration, a Wes Anderson-style nostalgic Indian classroom setting, and they explicitly state, no glowing brains, no binary code floating in the air, no blue laser matrix tech tropes.
Just analog reality.
A wooden classroom table viewed from slightly above. On the left side, a ripe yellow-orange mango, and taped to it is a messy, handwritten ballpoint pen label that simply reads apple. On the right side, an open notebook with a few hand-drawn scatter plots and a yellow pencil.
The whole visual is tactile and intentionally imperfect.
It's designed to make a busy executive stop and think, wait, why is that mango labeled apple? Before they even read a single metric. It strips away all that intimidating tech jargon and forces the viewer to confront what bad data actually looks like.
What's fascinating here is a point raised in the comment seeds attached to this post-mortem. It's a critical nuance that takes this mango-apple analogy one step further. And frankly, it's terrifying.
Yes, so.
Well, the analogy is highly effective for explaining supervised learning, but it breaks down in one very specific, very vital way. A human child eventually will push back.
Right.
At some point, that child is going to walk into a grocery store, see a real apple, or talk to another human being and say, wait a minute, that doesn't look like an apple. It doesn't taste like an apple. You have been lying to me. The child possesses sensory context.
A machine learning model never, ever does.
Never. It has zero intuition, No common sense, no external sensory apparatus to tell it whether its training labels make sense in the real world. It exists entirely inside the dark box of its training parameters.
So if the data says the mango is an apple, the algorithm will bet the entire financial future of the company on that mango being an apple, proudly and confidently.
Without a single second of hesitation. And this is why the postmortem stresses, in huge, bold letters, that a human review layer on your labeling pipeline is not some optional nice-to-have add-on that you push to a Phase 2 roadmap.
It's not a feature.
It is the entire foundation of the system.
Yeah.
Without human intuition continuously verifying the ground truth of the data, the most sophisticated compute cluster in the world is worse than useless. It's actively dangerous.
Which brings us to the real-world consequences of this kind of failure. Bad data, as we established, doesn't crash your system. It doesn't throw a 500 internal server error. So what does it actually do? It produces beautifully rendered dashboards that quietly bleed money for months on end.
The executive team thinks everything is fine because the dashboard is green.
Right up until the end of the quarter when someone finally reconciles the actual bank accounts and asks the terrifying question, why are our default rate projections off by a massive 30%?
A 30% miss on default rates for a lending institution is not a minor bug. That is the kind of systemic error that triggers regulatory audits and ends businesses.
It's the ultimate silent bleed. You're deploying capital based on a hallucinated reality. And the resolution to this specific story in Pune is just as shocking as the setup. When the team finally mapped the discrepancy and realized 40% of their labels from 2019 were actively poisoning the model, they had to make a brutal call.
They threw away the entire data set, all of it.
Completely started over. They spent 3 grueling weeks doing nothing but rebuilding those labels from scratch. Imagine being an elite machine learning engineer, recruited to build predictive AI, and spending 3 weeks staring at spreadsheets.
Just manually checking individual loan files. Yes, this is a default. No, this is performing.
Tedious, unglamorous manual labor. But look at the resulting numbers. Once they finally established a clean, verified data set, they ran the exact same model. They used the exact same team of engineers. They didn't alter a single line of that impressive architecture diagram.
And the accuracy of their credit scoring model jumped from an abysmal 61% to an incredibly robust 89%.
All of that optimization came purely from fixing the labels.
That 28-point jump in accuracy is the difference between an AI product that bankrupts a company and an AI product that makes it wildly profitable. And it leads us to a massive reframe in how organizations need to think about their resource allocation.
The uncomfortable budget split.
Exactly. The postmortem lays it out clearly. If you are a founder, a CTO, an executive planning a new AI build this quarter, 60% of your total budget should be allocated to data operations, manual labeling, data cleaning, pipeline auditing, continuous human review. Only 40% should be spent on the model itself, the compute, and the engineering talent.
60%. I want you to put yourself in the shoes of a seed-stage startup founder pitching to a major VC firm. If you walk into that room, pull up your pitch deck, and say, "We are raising $2 million, and we plan to spend $1.2 million of it paying human beings to painstakingly read spreadsheets and verify that our historical data isn't lying to us," you are going to get laughed out of the room.
Oh, absolutely. That does not look sexy on a slide deck. Investors want to hear about proprietary algorithms, cutting-edge neural networks, massive automated scale. They do not want to hear about manual data ops.
So what do founders do? They ignore the reality. They sweep the data ops requirements under the rug to make the pitch look cleaner, assuming they can just figure it out later.
Now, we have concrete data on exactly what happens when they make that assumption. The documentation provides corroborating evidence in its first comment seed. The author notes that this 60% figure isn't just a theoretical guess. It was reverse engineered from their own burn rate across 4 different client projects the previous year.
Yeah, let's look at those client projects.
2 of those clients aggressively constrained their budgets, allocating under 15% for data preparation and labeling, the operational result. Both of those projects blew past their delivery timelines by a factor of 2x. They doubled their expected time to market.
And the failure pattern was identical in both cases. The engineering team simply assumed their existing data warehouse was clean because nobody had explicitly complained about it yet.
Nobody has complained about the data yet. Has to be the most dangerous data validation strategy in corporate history.
It really is. So for you listening right now, if you are at a seed stage company or managing an internal project on a tight budget, the author gives an incredibly practical, actionable stress test in the third comment seed. It's brilliant in its simplicity. Let's call it the 500 row
I
test.
love this test.
Before you write a single line of model code, before you provision any expensive cloud compute, export 500 random rows from your current data set. Just 500. Have two different people on your team label those rows completely independently. They cannot talk to each other, they cannot collaborate. Then compare the results.
This is where the rubber meets the road. Let's walk through what happens. Say I look at row 42, a loan that was 30 days delinquent but eventually paid off. I mark it performing because the principal was recovered.
Right, makes sense.
But you look at the exact same row, see the 30-day delinquency, and mark it restructured because it technically triggered a late fee protocol in the system. The data itself isn't corrupted, but our human interpretation of the business logic is entirely fractured.
Exactly. And the rule from the postmortem is this. If your two human labelers disagree on more than 10% of those 500 rows, you have a fundamental consistency problem in your organization. If the humans building the system can't agree on what the ground truth of the data actually means, no fancy machine learning model is going to save you.
The algorithm will only mathematically amplify your internal confusion. You have to halt the project and fix the human consistency first.
The author explicitly notes they learned this lesson the extraordinarily expensive way.
It's a phenomenal, low-cost stress test. And before we pivot away from this Pune case study, I briefly want to analyze a meta layer included in this documentation that's quite revealing about corporate communication.
The quality gates table.
Yes. The source includes this quality gates verification table, which maps out exactly how this story of failure was intentionally engineered to appeal to different audiences within an organization.
It's so smart.
It points out that the narrative is specifically designed. So the CEO sees the 60% budget reframe as actionable, protective business advice. Meanwhile, the junior ML engineer reading the same document feels deeply validated because it publicly acknowledges the painful hidden reality of bad labels they deal with every single day.
And competitors or skeptics can't dismiss the postmortem as just theoretical whining because it is anchored by highly specific, undeniable metrics. 11 weeks of wasted time, 40% mislabeled data, a 61 to 89% accuracy jump, a 30% miss on financial projections.
It's a masterclass in communicating a deeply technical, foundational failure in a way that resonates across the entire corporate hierarchy, forcing everyone to care about data hygiene.
It takes the completely invisible problem of data rot and makes it tangible, expensive, and urgent. Okay, so we've just seen how predictive machine learning models fail spectacularly because of bad, neglected input data. They learn the wrong rules perfectly.
Right.
Now we are going to shift our focus entirely. We're moving from the structured world of tabular data and spreadsheets to the vast, unstructured oceans of text. We're going to look at our second artifact, the Wikipedia Field Guide, to see how generative AI, specifically large language models, fail.
And LLMs do not fail because a specific cell in a spreadsheet is mislabeled.
No. They fail because of the very nature and mathematical gravity of the internet text they were trained on.
The transition from tabular data to text changes the surface area of the problem. But the underlying philosophical theme remains identical. The output is entirely dependent on the nature of the input. And without strict human curation and enforced boundaries, the system defaults to a state that is confidently wrong.
Or, in the specific case of large language models, it defaults to being confidently, aggressively generic. Here's where it gets really interesting, because when an LLM fails, it doesn't throw a massive 30% error on a financial default rate that an auditor can catch. It does something much more insidious.
It gives you a paragraph of text that sounds perfectly grammatical, completely authoritative, and deeply profound, yet conveys absolutely zero verifiable information.
It replaces knowledge with vibes.
Exactly. And to understand why this happens, we had to look under the hood and understand the core statistical failure at the heart of large language models. The Wikipedia Field Guide we're analyzing identifies this fundamental mathematical flaw as regression to the mean.
Regression to the mean.
We have to remember how these systems actually function. LLMs are not massive databases looking up discrete facts in a digital encyclopedia. They are statistical inference engines. They're predicting the next most likely word or token based on the billions of words they have ingested during training.
Because of that architectural reality, they naturally smooth over anything that is rare, highly specific, jagged, or nuanced.
If a historical fact is highly unusual, it represents a statistical outlier in the vector space. The model's natural mathematical inclination is to pull that rare outlier back toward the center to replace it with something statistically common, broadly applicable, and vaguely positive.
The field guide gives a perfect, highly specific example of this regression to the mean in action. Let's say you're prompting the model to write a biography of a niche historical figure. The specific rare, beautiful fact about this person is that they invented the first train coupling device.
That is a concrete, verifiable, highly specific piece of human history.
But to an LLM, that specific phrasing is statistically narrow. It doesn't appear often in the training data compared to broader business terms. So the model will effortlessly erase that specific historical fact and replace it with a generic, statistically probable platitude. It will confidently output a sentence telling you that this person was a revolutionary titan of industry.
And this is why this mathematical smoothing is so incredibly dangerous for you as a reader, a student, or professional relying on these tools. It's not just that the writing is boring, though it is intensely boring to read. The real danger is the active erasure of specificity.
Actual verifiable facts are being statistically sanded down and replaced by generic filler.
It's an erosion of human knowledge. The internal field guide we're looking at categorizes this specific type of output, this AI speak, into 4 distinct recognizable buckets: content inflation, tone distortion, structural tics, and technical artifacts.
We're going to break these down completely so you can spot the matrix instantly when you're reading an article, an email, or a report. Let's start decoding this AI speak, opening up the first bucket: content inflation and tone distortion. The very first major tic the guide identifies is something it calls significance puffing.
Puffing.
This is when LLMs reflexively append massive statements of historical or cultural importance to completely mundane neutral facts. They just can't help themselves. They are incapable of just stating a fact. They have to tell you why that fact is the most pivotal moment in human history.
The document provides several clear examples of the exact phrasing LLMs use to achieve this puffery. You'll constantly see things like stands as a testament to, or leaves an indelible mark on, or reflects broader societal shifts.
Yes, all the time.
For instance, instead of just outputting the factual sentence, the local transit station was opened in 1954, the AI will instinctively bloat it into. The local transit station was opened in 1954, marking a pivotal moment in regional transportation that stands as a testament to mid-century urban development.
That entire second clause, the significance puffery, adds absolutely nothing verifiable to the sentence. It is pure, unadulterated statistical filler.
So how do we fix it? If you're managing one of these models, or even just writing a prompt for your own use, the guide provides a strict operational rule. You have to explicitly train or prompt the model to distinguish between factual claims and significance commentary.
If the model attempts to state an opinion on why something is important, it needs to provide a specific, named citation to justify that importance.
You can actually add a self-check instruction in your system prompt. Tell the AI, review your output. Does this clause add a verifiable fact, or does it just editorialize about importance? If it is just editorializing, delete it immediately.
Moving to the second major issue in this first bucket, we have promotional tone default. Even when tasked with writing about incredibly neutral, dry, or even negative topics, LLMs default to what the field guide calls brochure speak. They sound like an overly enthusiastic travel agency trying to sell you a timeshare.
Why does this happen? Because a massive percentage of the internet text they trained on corporate websites, SEO blogs, marketing copy is written in this exact tone.
Oh, I despise this one. Once you see it, you cannot unsee it. The field guide provides a hit list of words that are dead giveaways. If you see the words nestled, vibrant, rich cultural heritage, breathtaking, boasts, or the absolute worst offender, a rich tapestry, you are almost certainly reading AI-generated text.
A vibrant tapestry of innovation.
Yes. The guide provides a brilliant side-by-side comparison to show how deeply this distorts reality. The preferred factual human output describing a location is simple and informative. The town has a population of 12,000 and hosts an annual cattle market. That tells me exactly what I need to know.
But the AI's default garbage output, it will look at those facts and generate. The vibrant town has a rich cultural heritage, boasting an annual cattle market.
It has taken a specific demographic fact and a specific agricultural economic event and ground them down into a meaningless, frictionless marketing slogan.
To combat this, the guide suggests implementing hard negative constraints. You can't just ask the AI to be objective. You explicitly prohibit adjectives stacking around descriptions of places, people, or events in your system prompts. You literally have to tell the machine, do not use tourism-style adjectives like nestled, vibrant, or rich under any circumstances unless you are directly quoting a verified primary source.
You have to aggressively force the model to reward specificity over sentiment. Next up in the tone distortion bucket is vague attribution, which is basically weaponized weasel wording. This is where the LLM conjures up phantom authorities to make its generic claims sound academically rigorous.
You see this constantly in AI-generated thought leadership articles. Experts argue industry reports suggest, observers have noted, several critics claim.
It's a highly manipulative statistical trick. By using vague attribution, the AI is creating a false sense of consensus. It implies that a large respected body of literature agrees with its generated statement, when in reality it's often citing nothing at all, or maybe hallucinating a trend based on disparate data points.
The fix here requires strict accountability. You must ban these generalized attribution phrases from the model's output entirely. The rule is simple. It cannot say experts argue. It must be forced to say Dr. Sarah Smith argues in the 2023 Journal of X. If it cannot name the human being, it cannot make the claim.
The final tick in this first bucket is one of the most subtle, but it's incredibly annoying once you tune your ear to it. The guide calls it superficial in-clause tacking. The language model has this terrible grammatical habit of ending sentences with a dangling present participle, just to force a feeling of unearned profundity onto the end of a thought.
Yes, it's a mechanical synthesis of insight. The model will present a basic fact and then mechanically tack on a dependent clause, like contributing to the region's cultural identity, or highlighting its lasting significance, or underscoring the importance of innovation.
It's a structural trick designed to make a simple, flat statement sound like deep analysis.
And if we step back and look at how these ticks compound the puffery, the vibrant tapestries, the vague experts, the trailing in clauses, you realize how rapidly they transform informational text into pure marketing copy. It completely erodes the reader's trust.
When you read this kind of text, you feel like you're being sold a narrative, rather than being informed of the facts. The text becomes incredibly frictionless, but it provides absolutely no intellectual traction.
Exactly. You finish reading a dense, 3-paragraph AI-generated email or a summarized article, and you pause and realize you haven't actually learned a single new, concrete fact. It's just a perfectly formatted word salad of vibrant tapestries, leaving indelible marks.
Okay, so that thoroughly covers the words and the tone, but the Wikipedia field guide goes a step further. It points out that LLMs also betray themselves visually through structural heuristics and formatting flaws. This is our next bucket, and I find this fascinating because it shows how the AI's training data literally dictates the physical layout of the text on the screen.
The most prominent structural tick the guide flags is what it calls the rule of 3 default. LLMs have a deeply ingrained, almost unbreakable habit of structuring lists, examples, and supporting arguments into exactly 3 items. If you ask it for historical examples of a phenomenon, you will almost always get a bulleted list of 3.
Why 3? Is there some underlying architectural reason the neural network prefers the number 3?
It's not a hardware constraint. It's a direct inheritance from the persuasive and marketing content it consumed during training. In human copywriting, public speaking, and rhetoric, the rule of 3, or a tricolon, is a standard psychological technique used to make things sound balanced, satisfying, and memorable.
Like blood, sweat, and tears.
Or mind, body, and spirit. The AI has absorbed this syntactic pattern so thoroughly that it mechanically groups everything into 3s, regardless of whether the specific topic actually warrants 3 examples. It values the rhythm of the text over the accuracy of the quantity.
To counter this, the guide suggests deliberately instructing the model to vary list lengths, explicitly forcing it to provide 2-item or 4 to 5-item lists to break that recognizable artificial rhythm.
Then we get into what I like to call the visual assault of AI formatting, the formatting abuse. The guide notes that LLMs absolutely love to bold every single important phrase in a passage. Every key term, every proper noun, every statistic gets heavy bolding.
The result is what the field guide accurately describes as a slide deck aesthetic. It takes what should be flowing paragraphs of prose and makes them look like a highly technical read-dim file on a GitHub repository.
The model is attempting to be helpful by pre-highlighting the key takeaways for you, assuming you're skimming, but it completely ruins the actual reading experience. The guide demands a strict formatting rule. Boldface must be restricted strictly to the first occurrence of a subject's name or defining technical term, and nowhere else.
Closely related to this visual clutter is the inline header habit. Anyone who has used an LLM has seen this. The model will output a bullet point, followed by a bolded header phrase, followed by a colon, and then the descriptive text. For example, bullet point, bold economic impact, colon, the town's cattle market generates.
Yes. Every single list generated by an AI looks exactly like that. It's inescapable.
It's exhausting to read in large volumes.
The guide points out that this specific structure is inherited from the millions of internet listicles and SEO how-to guides it ingested. The fix here is to demand that the model convert these rigid, segmented structures into actual flowing paragraph prose, unless it's outputting a genuine data table or a highly specific chronological step-by-step sequence.
We want narrative prose, not bulleted subheadings for every single passing thought.
Another formatting tell that reveals the AI's hand is the massive overuse of the M-dash that Longash used to break up a sentence. LLMs use the M-dash at a far higher frequency than average human writers. They deploy it to artificially punch up clauses, mimicking the dramatic rhythm of sales copy.
The field guide has a great example of this M-dash abuse. A city shaped by its geography and its people to become a crossroads of culture. It's so incredibly melodramatic. Just use a comma, or better yet, rewrite the sentence.
The guide suggests putting a hard limit in your prompt of 1 M-dash per paragraph at maximum to stop the AI from constantly trying to inject artificial drama into the pacing.
Finally, in this visual section, we have the bucket of technical artifacts and context. These are the jarring moments when the AI completely forgets what kind of document it's supposed to be writing and reveals its nature as a chatbot.
A glaring example is the inappropriate abuse of emojis. An LLM might use a brain emoji followed by the text cognitive pattern, right in the middle of a formal, professional, legal, or academic document.
For the AI, emojis function merely as structural organizational markers. But in human writing, emojis carry heavy contextual weight and belong strictly in casual or social contexts.
The guide recommends an outright blanket ban on emojis as section markers in any informational writing.
And we can't forget my absolute favorite technical artifact, the verbose meta-commentary. It's that incredibly annoying, obsequious habit where the AI finishes writing the essay or the code and then adds a little conversational note at the very bottom. Would you like me to turn this into Wikipedia markup? Or I hope this detailed breakdown helps? Let me know if you need anything else to complete your project.
It instantly shatters the illusion that you're reading a finished, standalone document. You have to explicitly instruct the model. Produce the requested content only. Do not include introductory filler, do not include conversational sign-offs, suppress all meta output outside the document itself.
There's also a deeply fascinating point raised in the guide about context mismatch, specifically regarding the variety of English used. Because the vast, overwhelming majority of internet training data is American, LLMs naturally default to American English spelling, phrasing, and idioms completely regardless of the topic they're writing about.
The guide brings up an excellent illustrative example. If an Indian writer is prompting an AI to write an article about an Indian university, the output should absolutely not be in American English. The word color should have a U. Organize should be spelled with an S, depending on the local Commonwealth standards.
But the AI will default to American standards unless forced otherwise. The model needs to be instructed to detect contextual signals in the prompt, like the specific geography of the topic or the user's input vocabulary, and match the appropriate English variety.
When it fails to do this, and you have an article about a historic building in London talking about its vibrant colors without the U, it's a massive, immediate tell that the text is machine-generated.
Okay, we've thoroughly cataloged the flaws. We know about the significance puffing, the dangling clauses, the aggressive bolding, the rule of three, the timeshare brochure tone. We see the matrix now, but how do we actually fix the machine? How do we take this knowledge and apply it?
If we connect this to the bigger picture of AI deployment, the Wikipedia Field Guide doesn't just complain about the state of AI writing, it offers a highly structured synthesis of solutions. These 12 pointers we've been discussing are designed for two completely different levels of application.
First, they're actionable right now for system prompt engineering.
Meaning you, the listener, can paste these exact rules into your custom instructions in ChatGPT or Claude today to immediately improve your output. Second, on a macro level, they serve as highly specific fine-tuning targets for engineering teams doing RLHF reinforcement, learning from human feedback, or direct preference optimization. They provide a roadmap for how to train the next generation of models to actually write like informative humans.
So practically speaking, what can you, the listener, actually do with this information today? The field guide helps prioritize the attack. Out of all 12 pointers, it identifies the 3 absolute highest impact fixes that you should implement first, because these address the deepest statistical failure modes, not just the surface level stylistic formatting.
First, kill the significance puffing. Stop the model from saying stands as a testament.
Second, eliminate vague attribution entirely. No more experts argue without a name.
Third, and perhaps most importantly, prioritize specificity over generality. Force the model to retain that rare specific fact about the train coupling device, instead of allowing it to smooth the person down into a generic titan of industry.
Implementing those three fixes alone will dramatically, noticeably improve the quality, density, and trustworthiness of any AI-generated text you produce.
They force the underlying model to behave much more like a rigorous researcher presenting verifiable facts, and much less like a PR representative desperately trying to smooth over the details with positive vibes.
And for immediate, practical, everyday use, we can reiterate the specific negative constraint list derived from the guide. You can literally add a single, powerful sentence to your prompts right now that actively bans these crutch words. Tell the AI, do not use words like delve, tapestry, crucial, pivotal, vibrant, nestled, or showcase. Just ban them from the vocabulary.
Furthermore, force the AI to use basic copulous, basic, unadorned verbs. Tell it to use is, are, and has, instead of bloated passive verbs like serves as or boasts.
If a town has a museum, it has a museum. It does not boast a museum. You'll be absolutely amazed at how much cleaner, denser, and more human the text sounds just by aggressively removing those specific statistical crutches.
It is entirely about enforcing boundaries. Just as the data engineering team in Pune needed a manual human review layer to enforce strict boundaries on their tabular data to prevent a 30% financial miss, anyone utilizing an LLM needs to enforce strict, unforgiving constraints on its vocabulary and its structural output.
Left entirely to its own statistical devices without human guardrails, the system will always regress to the mean. It will always choose the mathematical path of least resistance, which results in generic, bloated, confidently wrong output.
It's been quite a journey today.
It really has. Let's summarize exactly where we've been and what we've uncovered. We started in Pune, India, looking at the hidden systemic dangers of untouched, mislabeled data from 2019 that confidently projected the wrong default rates for an entire financial institution.
We learned that an impressive, flawless architecture diagram and unlimited compute power mean absolutely nothing if 40% of your foundational ground truth is rotting, and that you probably need to be aggressively advocating to spend 60% of your AI budget on unglamorous data ops.
Then we move from the rigidity of tabular numbers to the vastness of generative text, uncovering the statistical smoothing of large language models that confidently erase specific, beautiful, rare historical facts in favor of a rich tapestry of generic marketing-style nonsense.
We learned exactly how to spot the puffery, the rigid rule of three, and the promotional travel brochure tone.
The common thread running through both of these vastly different sources is undeniable. Without rigorous human curation, without strict enforced boundaries, and without a very healthy dose of skepticism regarding what the machine is telling you, AI defaults to being confidently wrong.
The machine, no matter how vast its parameter count or how fast its processors, is only as good as the human intent behind it and the human oversight guiding it.
I couldn't agree more. So, a direct, practical call to action for you listening right now. If you are managing or building a predictive model this quarter, remember the 500-row labeling test before you write any code. Check your human consistency first.
And if you're just reading reports, articles, or emails tomorrow morning, keep a sharp eye out for those trailing in clauses and that insidious word, vibrant.
I promise you, once you see the AI speak, you will never be able to unsee it.
Before we sign off, all of this raises a massive structural question. A final, provocative thought for you to mull over. We've established today that current LMs mathematically regress to the mean. They smooth out the rare, beautiful, highly specific outliers of human history into a generic, statistically average mush.
Right.
Now, right now, these current frontier models are trained primarily on text that was written by actual human beings over the last few decades. But what happens to the next generation of AI models? What happens in 3 years when the internet they scrape for their new trading data is already heavily flooded with this generic, artificially generated AI speak content?
Oh, wow.
If an AI trains on the smoothed-out output of another AI, will the mean they regress to become even lower? We could be looking at an accelerating, catastrophic feedback loop of vagueness, a digital reality where specific, unusual facts simply disappear from the internet record altogether, replaced entirely by an endless, frictionless sea of vibrant tapestries and indelible marks.
That is a chilling thought. The idea of specific human history just dissolving into generic vibes is exactly the kind of thing we love to dig into here. Thank you so much for taking this deep dive with us today. Keep questioning the data, keep enforcing those boundaries, ban the word delve from your vocabulary, and we will catch you next time.